So yeah, we last month we kind of went over Unity 6 and all of the new features and stuff for it. And now I want to kick over into the multiplayer part of it, which was also a kind of a big rollout for a lot of their newer features here. So for the editor, I guess we'll start out with what we're actually working. So this is Unity 6 preview 6.0.4, and we'll look into some of the pack installed. So for the multiplayer stuff, we will need authentication. I guess there is a newer version out now that actually added. Oh, they fixed some stuff. We will need, I don't know if we're using the input system here or not, but that is built in. But the multiplayer center we will look at. This is 0.3, and also the quick start content. We'll see what that's about as well. I am using multiplayer play mode 1.2.0. The multiplayer services. This is on 0.4.2. This is going to be the primary way that we will be using multiplayer stuff. And what the multiplayer services actually does is it will combine the relay, lobby, matchmaking services all into one. That's all of them. We'll look at some of the multiplayer tools, and the multiplayer widgets is the other new one, which is on 0.1.1, as well as netcode for game objects 1.9.1. This also has the anticipation system and some other additions to network variables and a little bit more abilities in that we might go. And I believe that is it. See, we are using transport 2.2.1. I think services core is built the other services as well. I believe that is all we need for this particular demo. All right, so here we have a fresh scene, and we'll look into the new multiplayer center here under the window multiplayer center. And what this will do is this will give you a little kind of a recommendation chart, a little wizard that you can go through. If you're not sure what all you might want to install, this will recommend packages for you and then let you install them all with just a click. So depending on your genre of game, different solutions will be more recommended than others. So if you're going to do like a first-person shooter that is fast-paced and competitive and a client server architecture, you'll probably want to end up using netcode for entities because it has a built-in client prediction system and it is better for higher player counts and faster paced action. If you're doing, say, co-op survival game that's like lower player count, something like a Valheim or something of like 8 players max, then netcode for game objects is really good for this, and it also will have your other services that can work with game object side of it. You can just go in here and switch things up. So if you still want to use entities, whatever, it will let you do that. So the multiplayer widgets and the multiplayer tools are not compatible with entities, so it won't let you install that. But the other services you can use with entities. So your lobby system, your relay system, Livevox for voice chat, multiplayer play mode will work. If you just want to use client hosted or kind of a pseudo peer-to-peer networking, you can do that as well with the relay service. And if you're doing something like a card game, like a Hearthstone or any of the other like turn-based deck builders out there, for that you wouldn't need a netcode solution at all. You would use cloud code to process all of your data, and you can just send commands up to the cloud. It'll process it, spit you back out the updated game state, and then you can update everything there. All right, so I think that's about everything for dations. If you want to do like a MMO type game, that would be custom netcode. So you'll be basically on your own writing the low level stuff with Unity Transport. but the other services, again, will all work for that. In our quick start here, this is just kind of where the documentation and stuff are easy to get to. You can open up your various windows for multiplayer tool, for multiplayer play mode, get that in a sec. But also for netcover game objects, there is a basic scene setup, which I can show you what that actually is here. We click on this, and then this will spit out some stuff in our scene. And we can just go ahead and close this. Actually, going back to that. Oh, there is a quick start widgets, and we'll look at the widgets later. All right. So yeah, for this, we have a little UI set up to start our host and start our client. When you're using netcode for game objects, you'll have a network manager here and a network prefab for your player. So every player, every client that joins will automatically spawn a player prefab. The player prefab is going to be here in our assets. It just has a network object. It's going to be the component that is tracking things between the various clients. Client network transform. So this will be a client authoritative, I guess really owner authoritative movement for syncing the X, Y, and Z of the position, rotation, and scale of our object. There's also other settings you can throw here. So for the position threshold, this will be the amount that it has to move before it will start syncing to the other client. So if you're just moving very little bit, this will prevent jitter. You can also send unreliable deltas. So this will, by default, most of everything in netcode is sent reliably. So if your connection is a little bit flaky or whatever, a packet gets dropped, it will automatically try to resend the packets. But for something like movement for a player character who might be moving all of the time, every frame, that's a lot of packets to be sent and resent if anything goes wrong. And that can end up snowballing and creating a bunch of lag for your game. So if anything's unreliable, you just send it and forget it. And if it drops, it drops. There'll be another one in the next frame. We do have a little client authoritative movement script and a color setter. I haven't actually seen it. Okay. So yeah, in here, all this is doing, grabbing our inputs and then just directly moving the position by whatever. That's all. Here in our network manager, a couple of the other settings, which we have our tick rate by default. This used to be 50. I guess they changed it to 30 reasons. Here we have connection approval. This will be a separate callback that will get handled. So if you have other verifications that you want to do for authentication purposes, if you have a third-party authentication for logging in through Steam or Facebook or Google or whatever, you can handle all of that within this connection approval callback just to further authenticate. I don't think we'll be using that much. And then down here in the Unity transport, this is where you set your addresses to send and receive data. We'll just leave it here as localhost just for right now, and the default port 777. You'll also, if you're testing with another computer, you'll want to check allow remote connection. Let's look at, before we hit play, the multiplayer play mode. So what this will do is this will spin up basically 3 other kind of stripped down editors. Got one open here, player 2, and really it's just kind of a game window. And when we hit play, you'll see that it just kind of plays here. I haven't added this. So here, both editors are starting. Oh, I didn't say. So one thing about the multiplayer play mode is you need to save the scene in order for it to replicate to the other. So once we save, we have our updated UI. So we'll play, and I don't know if the player is going to fall forever or not. Okay, so in my main editor, I'm going to start host. Hey, I can move around, and here, I'm going to start client, and I can here, see me there. And there we go. Now network. You're not going to see much lag or anything because we're all connected through the local host on the same computer. Let's stop this. So when we stop playing on the main editor, they both stop. All right. So part of the multiplayer tool We have runtime stat monitor here, and we have a network simulator here. There's also a network profiler. I'm not going to get into that just yet. Our stats monitors will show up here in the left. Use these sliders to position them around, and this show. We also have our network simulator here. So with this, you can simulate various network conditions for different devices. So if you wanted to test it out on what this would look like on mobile, DSL, whatever. So say we have 5G, should be fine. Oh, I didn't save. So here's our stats. Say host. Don't think our stats here when I say anything. We're the host, so we're not sending anything to anybody until we connect. All right. So here you can see it's a little bit chunky compared to what we're actually here. See, but that's due to the network simulator. Can turn it off. Might have to connect. All right. So we can get rid of this. So this is just connecting directly to our host and our clients, just directly through IP. For an actual game with actual players, you'll want to not have to type in your host IP address for a variety of reasons. This is what the relay system is for. It is a Unity game service that Unity provides, basically a relay server that will relay your packets through firewalls across the internet, whatever, to the other clients. So all right, so I guess we'll just delete this because we don't need temporary. Now, because of the widgets package that we installed here, you can just right click here, go down to multiplayer widgets, and then you have this create, join, and it'll create info and join. So for create, we can just pop a button here, and this will create a quick create button. This will create a session for us, and a session is a lobby with a relay created for it. And I suppose we should look into actual services. So in the general settings, when you create when you connect your project to Unity Cloud, you will get a project ID, and this project ID will be tied to your various services here. For authentication, you can log in with any of these authentication providers. For the most part, we're going to be logging in anonymously, which is tied to your physical device here. So if you log in on a different computer, it'll be a different player. We have various environments that you can use and the other services. Here it's Unity Cloud. The Unity Cloud is where all of your Unity game services will live. For this project, we are going to be using the lobby service and the relay service. So you'll want to set these up first. Basically, you just click through the kind of configuration wizard here, and you can configure what you want your minimum and maximums to be for your lobby. So if you're just doing a standard like 5v5 first-person shooter, you might just want your maximum lobbies to be 10 players. You might just have a minimum player slot of 2 for a match created. You can also use it with the relay, which is what we are going to be doing, and you just want to make sure that you're getting to the overview screen. So once you have this enabled, then we'll be able to create our sessions. So you will see here in our quick create sessions script, it's looking for a session configuration. I believe we can just create one. Nice. So here under multiplayer widgets, we have session configuration. I already have one here somewhere. So here in our session configuration, we can give it a name. Connection type can either have it have a direct connection or a relay connection. We're going to stick with the relay connection here. It'll have some default values that it will use to set up said session. All right, so back here in our script, we have some events here that we can subscribe to. So when you have joined a session, you can do some things like you can disable buttons, whatnot. And then we have our enter session button that will leave automatically set. All right, so this session base here is just setting the basic configuration, and look up base. And what session base will do is we have the session manager singleton here that is going to fire off this enter session. This will grab the session data that is set in here and then create our session. And then can look at session. And basically there is also matchmaking as well as part of our action. So we could use matchmaker as well, or quick join. We are, I believe, quick create here just fails down into regular create, but it will, for the session name, it'll just create a new GUID for our session. So right now, this is just creating a session and then the host is joining it, but we don't have a way for our clients to connect to it. For that, we will use multiplayer widgets join, and we can join with a code here. So here we can create a session and then we can join a session, but we don't have a code to join with. And that is info go session. And then this we find. All right, so super up, and keep an eye on the console here. You'll see it do a bunch of stuff once we actually start here. We will see a code pop up here. There we go. Yeah. So here we are around. So what this did was this will initialize your services. We signed in anonymously. We grabbed our player ID. This is the quality of service that will look for the lowest ping region and then create a relay for it. So this will ping every servers out there, find one that is the lowest, and then join it. For us, that is US Central, and then we joined it. And then here we're spitting out our metadata, which is the relay join code, but you will notice that this is different from the code we got here. So this code, I believe, is the lobby join code. So the session will create a lobby and then create a relay, and then it will add the relay code to the lobby data. So all we have to do now is join this lobby, and then we will automatically connect to, so I guess we could. So here in the multiplayer play mode, by default, you're only seeing the game view, but you can hit the layout here and go into your inspector, and so our session manager here and the network manager, these get marked as do not destroy on load. They'll persist between scenes. If you're loading up new scenes for stuff, this won't get destroyed here, and this is case sensitive. So yay, we join. I think I still okay. So you will see that the RTT to server, the return trip time, even though we're on the same computer, it is going out to the relay server and back. So our RTT time, our ping time will be higher. But with this, you don't really have to do any weird network simulation things to test out average latency. This will just kind of work. All right. So if you don't want to type in a join code for whatever reason, you can. This is another widget we can use, which is multiplayer widgets session list. Okay. Now what this will do is this will give us a list of our sessions. Since our sessions are just lobbies, this is basically just a list of all the lobbies that are out there. So we created this. So here we have the name of our session, which is just a random GUID, and we also have our player count. So it is 1 out of 100. You can tell which ones you may or may not want to join. You can also use this to filter out full lobbies or sessions they can be privated, have passwords, and be here. We can refresh and refresh to player. There's also a number of session events that you can subscribe to. So if a player joins, you can update your player list or whatever whenever the session actually changes. I believe that is all of widgets. There's also create a session, and this is similar to create, but you can give it your own. The network simulator can also do lag spikes. So if you want to see what happens when, if you're on mobile or whatever and you're switching cell towers, you'll get like a 500 millisecond spike, and you want to have to deal with that. Here we can grab our name. I didn't really should grab this. Okay, here better. Now we have our own unique names for our session. and join. It's like, so here, like when we join and whatnot, you would use like your join sessions to disable various UI and stuff. So we went through create, info, session code, and matchmaker. I never got matchmaker to work right. I'm not entirely sure why that is not working, but here in your matchmaker, you create a queue. This queue we call default. In the queue, you can create, you make your settings, like how many players per ticket and whatnot. And in the pool, you can choose your hosting type. You can either matchmake into your dedicated servers if you have dedicated servers running, or you can actually matchmake into the relay peer host. This is new as well. Don't remember if this is still like in a beta state or not, but our project got approved. This should be rolling out to everybody soon, if not already. So you have timeouts. You have various rules here. You'll need at least one rule. This one is just kind of a default rule. It's a free for all. Everyone's on their own team of, it should be a team of one. Everybody should be on a team of one, and with a maximum of 100 players, I believe it is. And for your rules, it first will try to fill up the match, and if it doesn't find a full match or can't fill up a match within whatever 30 seconds or whatever, it will loosen its rule, and then we will try to do the next smallest with 20 as the minimum, and then after another 30 seconds we will replace our minimum with 1. So even if we have just one player, it will still start at least. And I think I'll change doink replicas, should players, and 5 seconds and 2, so it actually waits for another player to start a match. See if this. All right, we'll see what happens here in our create session with matchmaking. We get a default queue name, which is just default, which is what we named it. The ticket attributes here, these are just key value pairs that you can use to sort your matches by. So if you have a rule for map types or player composition and whatnot, there are ticket attributes. There's also player attributes as well. So when you create your player for matchmaking, you can give it like your character archetype, say like you're a healer or a tank or whatever, and the matchmaking will it can try to match up team comp. So you can say you can't have a team of all healers just by accident. But for this, I don't think we're actually going to use that. And let's just see what has been happening is when I hit matchmaking, it just starts a new host. I'm not sure why that's happening. It might just not be live. So that is kind of the basics of starting and creating a multiplayer session. I can go over a little bit of actually sending data back and forth between client and host. Other scene. Okay, this is another scene that I've created earlier, and for this one we are spawning different. So for everything that is spawned, we have a network prefab list. So anything that is spawned dynamically will need to be added to this list, except for I think even the player. These cubes here are regular just network objects with there's some anticipation stuff on here. We'll go over that probably next session with rigid bodies and network rigid body and transforming to sync. But since it's not actually being spawned dynamically, it doesn't have to be in the network prefab, so they can just chill out in the scene. But our player in our prefabs here, this does have a network player. Let's open this up real quick. So there are two main ways of sending data and syncing them across the network. The first way is with a network variable, and with this network variable, it has a various read and write permissions to it, and in general, there's only one owner of an object. If it is an in-scene object, like we saw with those cubes, that owner is always going to be the server, which is also the host. The host is a client and and a server running at the same time. The regular clients that connect, those will just be clients. And for like this network variable here, we just gave it owner write permissions. So only this owner can write to this. And every network behavior, which is similar to mono behavior, but it's network. Every network behavior needs to live on a network object, and network objects only have one owner. So for the players, the owner will be that client. Now you can give ownership of other objects to other clients. That'll be done on the server side, but that's kind of there is a new anticipation system. We'll cover that probably more in detail next month because it's a bit more involved in that. But the network variable takes a separate type, and this type has to be a value type. And for strings particularly, you can't just send a regular string out because that's a reference type. It's a whole thing. So we are using the fixed string bytes from Unity collections, and this is basically just a byte array that represents a string, but it's a set amount. So we always know what it is, and it will always send the full bytes too. So there's 5 or 6 different lengths of these. I think 32 might be the smallest, maybe. Yeah, hopefully that didn't break. But you can have either server write permissions or server read permissions as well. I believe the server can always read variables. And there is owner read and owner write. For our player data here, this is a custom struct here that we have that is just 2 strings and a health float. So your structs that for sending through either RPCs, which are remote procedure calls, or network variables, they have to implement iNetwork serializable. And to implement that, it is just this function here for network serialize. This will tell netcode how to serialize whatever values you have in here, your types here. So you can nest these. So if you have another struct that you want to bundle up and save, you can do that as long as it also implements iSerializable. The built-in structs are so yeah, there's the C# primitive types like your ints, double, float, whatever. Those can you don't need to re-implement iSerializable for those. But for the built-in ones for Unity is the colors, color 32, the vectors, vector 2, 3, and 4, quaternions, and A's. So for those, you don't need anything special. You can just throw those directly into your network variable or your RPC. Network variables also have this event called. So whenever they are changed and replicated over the network, you'll get this on value change when that happens. And this will give you the old value and the new value. So you can do here, when we spawn, we are grabbing the player name that we're putting in and then setting that to our player data. So the other players who we spawn in on, they can get our username. So that will automatically get that synced up. We're not going to talk about the re-anticipate, but this is part of the anticipation system. We'll go over that later. And then here we just have a little health bar that will automatically update our little stat bar at the top. Not showing RPCs. All right. So for RPCs, so an RPC is a remote procedure. And what that means is that this is a function that is called on one client or the server, and it is going to be run on another client or another server. So for this one, you need to put the attribute RPC in front of it or above it, and you have a send to parameter here. So this is actually where you're going to be sending it to. There are quite a few that we can automatically send to. So we can send to the clients and the host. You can send to everybody, which is broadcast it out. You can send it to yourself. You can send it to everyone that is not you, so you can broadcast it out, but you won't receive it. You can send it to everyone who is not an owner, not the server, and whatnot. There's also a specified in the parameters. So there are RPC send params that if you need to specify exactly who you need to send it to, you can do that. So if you have like a area of effect attack or something that is only damaging players within a sphere or whatever, then you can just send to just those players, or if you're doing direct message, whisper chat or whatever, you do it that way. But this was just going to the server. You can also send the delivery can be reliable or unreliable. Or by default, everything is sent reliably. So even if the packet gets dropped, it will continue to resend until it gets actually accepted. For this particular function, this is going to be called in fixed update, and since it's going to be called 30 times a second or whatever potentially, we're going to send this unreliable. So we're just going to send it, and we're not even going to wait for an acknowledgement. And what's going to happen is everything in the arguments here, the parameters, this is what's actually getting sent over. We'll go over more about this next time, but this input list is basically just your current what buttons you had pressed and on this frame, and then we're sending that to the server. The server is going to move our character around, and then it will update us on where the current position of our player is. And basically down here to call it, you just call it, you pass it in, you need to pass it, and that's it. The RPCs also have to end in RPC. That's just how the network manager knows what to do with this function. There are also custom messages that you can use as well. So if you don't want to tie your network variables and your RPCs to an actual network object in the scene, you don't have to. You can use custom messages, and there's a custom message handler that you can create that will handle all messages that come through, and then you can deal with them that way. It's a little bit more efficient that way. So yeah, that is kind of basics. Show you what it's kind of like. All right, so here what I'm doing is just giving a name here, player. This is actually going to get saved over into a scriptable object that I have over here that is loaded up. This will just save the player name in case we are changing scenes or whatever. And then here, same thing. Okay, so yeah, what I'm doing here is basically the same thing, but I just hit all of the things on when it joined. So here I have my player name, my little stat bar, and my dude running around. The little guy that is T-posing there, that is the server representation of where the server thinks that my player is, and then my animated character is where the client is. So since I am the host, it's lining up pretty well. And I've got some so my dude has player names are synced up here. Not exactly sure why I don't know why that not animated. See, I am animating on this one. I don't know what's going on. It's weird. The network animator is supposed to take which is that but the network animator is supposed to sync the animation states across the network without you having to actually do, and that just for down here where we're setting our speed for our player, that should sync across the network, but I'm not sure why other dude he's just not animated. But anyways, we'll go into deeper into how the anticipation works and how that can be used for client prediction stuff. And yeah, I guess that is about it. If you guys have any questions on this, please feel free to drop a comment or hit us up on our Discord, which should be a corner there. And yeah, next time we're going to talk about the client anticipation system and also a little bit about Netcode 2.0, which should be dropping sooner rather than later. So yeah, that's about it. I will catch you guys next time.